the unit vector. Multiplying the unit vectors by scalar. Which of these vector has same direction as that of this vector? So this vector has same direction as that of So as of now, we have discussed how to add and subtract vectors. Now in this video, we will discuss about unit vectors. So first topic will be the unit vector. And the next topic will be multiplying the unit vectors by scalars. And finally, the practice problem based on unit vector. So let's start with the first topic. What are unit vectors? Unit vectors are defined to be dimensionless vector of unit magnitude, and x cap is a unit vector along the positive x direction. This is positive x direction. Similarly, the y cap is the unit vector along the positive y direction. Now the question arises, what is the use of unit vectors? Why we discuss unit vectors? So unit vectors provides a convenient way to express a vector in terms of its vector components. So you should note one thing and then we'll proceed further on unit vectors, that a unit vector is dimensionless vector of unit length or unit magnitude. Now let's discuss what happens when we multiply a unit vector by a scalar. But before that, let us first understand what happens when we multiply a vector by a scalar number. So here we have this vector A. Now if we multiply this vector A by 2, then the magnitude of vector A will increase by a factor of 2, but the direction will not change, and this vector represents 2 times a vector. So direction is same, but the magnitude means here the length of this vector is increased by 2 times. This is what it means. Now next, if you multiply a vector by -2, then what is going to happen? In this case, the direction will also change and the magnitude will increase by a factor of 2. So this vector would represent -2a. Here the magnitude of this vector A is increased by 2 times, and the direction also reverses. Here the direction for A vector was this side, but for -2 times A vector, the direction just reverses opposite to this direction. So this is what happens when we multiply a vector by a scalar number. Now when a unit vector is multiplied by a scalar number, then it will result in a vector of same magnitude and dimension as the scalar. Now let's take this example. So we have this vector A, and earlier we studied that the magnitude of vector A can be represented as a sum of its scalar components. That is, the magnitude of A is equals to AX, the scalar component in x direction, plus the scalar component in y direction. This is what we studied earlier. In this similar way, we can write that a vector can be written as a sum of its vector components. So A vector is equals to AX x cap plus AY y cap. So this is the vector component in x direction, and this is the vector component in y direction. Now we can also represent it on the figure. So this is the vector component in the x direction and this is in the y direction. So this is AX x cap and this is AY y cap. And this x cap and y cap are the unit vectors along positive and positive x-axis and positive y-axis. Now the things are clear that what is the use of unit vectors. So by the use of unit vectors, we can write a vector in term of its vector components. We have just multiply the scalar component of a vector to a unit vector so that it becomes a vector component. So this is the use of a unit vector. Now we can also represent this vector components in another way. So let me just copy paste it. Just copy and paste. So I've just copied it and pasted it. Now I can take this vector from this position to this position. I'm not changing its direction. I've not changed its magnitude. I've just placed from one position to another position. And this we can write it here. This is AY, Y cap. Now if you see carefully, we can observe one thing. The vector components are the projection of a vector onto the x-axis and the y-axis. Here you can see this is the projection of a vector onto the x-axis, and this is what we call vector component in x direction. Similarly, this AY, Y cap is the projection of a vector onto the y-axis, and the sign of a vector component is positive if they point in a positive x or y direction. In this case, it is pointing in the positive x direction, so the sign would be positive, and here also it is pointing along the positive y-axis, so the sign will be positive. So this is how vector components will generally be shown in the later videos. Now we're going to discuss the applications of unit vectors. Now I've taken this example in the earlier videos where this vector C is the sum of vector A plus vector B. Now we studied that this vector A can be written as a sum of its vector components. So vector A can be written as, this is AX x cap. X cap is the unit vector along the x-axis plus AY y cap. Similarly, the B vector can be written as BX x cap plus BY y cap. Now by using this concept, we can write that the vector C, which is the sum of vector A and B, is equals to, now vector A we can write this way, so AX x cap plus AY y cap plus B vector is BX x cap plus BY y cap, and we can further rewrite as AX plus, I'm just taking the x component here, BX, now the unit vector x cap plus, this is AY plus BY and the unit vector y cap. So by using the unit vectors, we can easily add vectors. Similarly, if we want to subtract two vectors, so suppose D vector is equals to A vector minus B vector. So we can write this as AX minus BX x cap plus AY minus BY y cap. So this is the way we subtract vectors. So this all things, addition and subtraction of vectors, can be done easily by using the help of unit vectors. So this is all with this unit vector. Now one thing is left, that is a practice problem based on the unit vectors. Now let's discuss this problem based on unit vectors. Now we have these four vectors given, vector A, vector B, vector C and vector D. Now the question is that which of these vector shown in this figure has same direction as that of this vector, minus 1 x cap, minus 1 y cap. Now this vector is written in terms of its vector components. So the x component we have minus 1 x cap. So this would be minus 1 x cap. If we have taken this direction to be positive x axis, this is positive y. So negative 1 means this way. So minus 1 and this is x cap. Now next we have minus 1 y cap. So this would be this vector. It's basically a unit vector. So minus 1 y cap. Now the sum of this vector would be represented by this vector. This is the way we write, and this is the same thing we discussed earlier also. So this vector has same direction as that of this vector. Therefore the answer would be the C vector. That C vector has the same direction as that of this vector. So this is all with this unit vectors. Now in the next video we'll discuss about position, velocity vectors, displacement vector, and so on.